Okay, today we are going to start section 4.8, exponents and division. So last time we did exponents and multiplication, this time we're doing exponents and division. So when you have a division problem, oh, I have the wrong thing on, whoopsie, here we go. Okay, so if you have 7 to the 8th power, let's say, over 7 cubed. Okay, if you want to do this kind of the long way, this would be 7 times 7 8 times. 4, 5, 6, 7, 8. Divided by 1, 2, 3, 4, 5, 6, 7, 8. 7 3 times. 7 times 7 times 7. Okay, so like we did before, we can cancel out. So there's 1, 2, 3. So we're left with 7 to the 5th on the top. Okay, well, an easier way to do that is to just take 7, 8 minus 3 and get 7 to the 5th power. Okay, so before when we did multiplication, you would add your exponents. Now this is only if they have the same base. Remember, the base is the big number. If it's the same base, then when you divide, you really subtract. So multiply, add, divide, subtract. Okay? So dividing powers with the same base. So the rule is, you'll notice that we're going to go through a few rules. Today we're going to add 3 more rules to our 2 the other day. Okay, so a to the m power over a to the n power is equal to a to the m minus n. Okay, so that's our rule for this part. Okay, so number 1, let's just do a few examples. Let's do 3 to the 8th divided by 3 to the 5th. Since our base is the same, you can just do 8 minus 5 and just do 3 cubed, which is 27. Remember, if there's a number taken to another number, you actually do have to write an answer down, an actual numerical answer. Okay, so 10 to the 7th over 10 to the 4th. Again, it's just 10 to the 7 minus 4, which is 10 cubed, which is 1,000. Remember, 10 taken to any power, it's just that many zeros. Okay. The third one, x to the 25th over x to the 18th. Okay, so that's just going to become x 25 minus 18. That should be an 18 right there. Equals x to the 7th power. And then you're done with that one. Okay. The last one for this little section, 12m to the 5th over 3m. So again, this is like before. We reduce, it's just a different way. We reduce, well, 3 goes into 3 once, 3 goes into 12 4 times, so you can just have a 4, or you can write 4 over 1 if you want, but then it's going to be m 5 minus 1. Remember, this is really a 1 right here. That's really a 1, okay? So 5 minus 1, you can have this all over 1 if you want. I'll just put it as a little dashed. Okay, so this is going to be 4m to the 4th. That's it. Okay, next little rule that we have is the power of 0, which we've talked about before. Remember how we said anything to the 0 power is 1? I'm going to explain, I'm going to show you why that is, or I'm going to try to. Okay, I'm going to show you why it's that way. Okay, if you have the numbers 5 over 5, what does that equal? Okay, well that equals 1. Any number over itself equals 1. A over A equals 1. Anything over itself is 1. So if you had, let's say, 3 to the 4th over 3 to the 4th, that should be 1. Okay, well if we use our rules that we just learned, that would be 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3, which those all cancel out. You should end up with 1. Or if we did our actual rule, 4 minus 4, which is 3 to the 0 power, which is 1. So you don't have to know that. I mean, this is just kind of showing you why anything to the 0 power is 1, because technically it's, you know, it could be b over b or b squared over b squared. Anything that would give you the 0 power would end up being 1. So anything to the 0 power is 1. Okay, and the rule is written kind of like this. A to the 0 power is 1. So anything to the 0 power equals 1 is what that means. Let me change my, let me see if this will go. Okay. Okay. So let's do a few examples of those. Okay. So if we have negative 8 squared over negative 8 squared. Okay, we all know that that would be, hopefully we would all know, this is negative 8 to the 2 minus 2, which is negative 8 to the 0, which is just 0. I'm sorry, hello, that's the whole point, which is just 1. Let me erase that. Hello. Okay, that's the biggest mistake because you end up just looking at that 0 and thinking it's 1. Let me get my pencil back on here. Woo! Because this should technically have a this. So this is another place where that that negative or those parentheses come in handy. Okay, you have to know that that negative 8 is in parentheses, because if that negative isn't in parentheses, then it'd actually be negative 1. Okay, so moving on, 6b cubed over 18b cubed. So you can just look at this and know right away this is going to cancel. Okay, or if you want to go ahead and reduce the fraction to 1/3 and know this is going to be b to the 0, which is just 1, can make it 1/3. You do not have to write all this out. You could just come over here and say, I know this is going to cancel, so I'm going to cancel b cubed over b cubed. I'm left with 6/18, which is 1/3. That's fine. I'm just kind of giving you some longer explanations. Okay, so an easier one, 50 to the 0 power, 1. Now where it gets a little tricky is 5x to the 0 power. That 0 is only to that x. It is not to the 5. If it was the whole thing was in parentheses, that'd be different. It's only to that x. So this really becomes 5 times 1. Again, you don't have to write that step. But you have to know that this equals 5 because that 0 is only to that x. Okay, I think we just have a little bit more. We have one more. Okay, so negative integers. This tends to be the one that can be the most confusing. We'll see how it goes. So negative integers. So let's say we have 3 squared over 3 to the 4th. Okay, so how we taught, the rule says that we bring it up to the top. So this would really be 3, 2 minus 4, which is really 3 to the negative 2. Okay, well, another way to do it, so let's just do this, would be 3 times 3 over 3 times 3 times 3 times 3. So when we cancel out, we're left with a 1 on the top and we still have 3 squared on the bottom. Okay, so you need to make the connection that this and this are the same thing. Okay, so whenever you have a negative, you flip it. If it was already a negative on the bottom, you would flip it to the top, which we'll get more into that in the next chapter. But right now, when there's a negative exponent, not the base, but whenever the is a negative exponent, you flip it to the bottom. So this would become 1 over 3 squared, which is 1 over 9. Okay, you flip it and get rid of the negative. So that would be 1/9 right there. Okay, so our rule looks like this. A to the negative n is equal to 1 over an, and this is only a cannot equal 0, which I think should have been with all the other rules, but okay. So you just take it and you flip it, and this is just kind of explaining to you why it is that way. I think we have a few examples and then we're done. Okay, so a to the 6th over a to the 8th. So a to the 6 minus 8, which is a to the negative 2, which is 1 over a squared. You just flip it. Okay, these two things are the exact same. All these things are the same. You're just simplifying it. Okay, and you will get to eventually where you'll realize, okay, if I have 6 on the top and 8 on the bottom, I'm just going to bring them down. I'm just going to subtract on the bottom. That is fine as well. Okay, you'll do it, but you just need to know this rule. If we have x squared y cubed over x cubed y, okay, again, I'm going to use the rule. So x 2 minus 3, y 3 minus, remember this is really a 1 right here, 3 minus 1. So this is going to give us x to the negative 1, y squared. Okay, so when you get something like this, is that right? Did I say that right? Yeah. So when I get something like this, this is the only one that's negative. Let me bring my colors back up. This is the only negative exponent. So that's the only one we move. This y squared stays right where it is. We bring the one with the negative exponent to the bottom. So it can just be x to the first. You can leave it like that, or you can just put y squared over x. Okay? Again, if you can look at this and know, okay, I have 2 x's on the top, 3 on the bottom, I'm going to end up with an x on the bottom. If I have y cubed on the top, y on the bottom, then I know I'm going to end up with y squared on the top. That is fine. You can do it that way. Okay? One thing I want to note is sometimes it'll say write your answer without a fraction bar. So what that means is this would be your answer right here. Okay, so in your homework sometimes it'll say write your answer without a fraction bar. So your problem might be this, like, let me just make one up. X to the 4th over x to the 8th. Okay, so x to the 4 minus 8, x to the negative 4th. This would be your answer without a fraction bar. If it says just to simplify it all the way or to use a fraction bar, then that's when you would flip it over. Okay, that's when you would then make it 1 over x to the 4th. You would do it that way. Okay, so don't let this little thing right here is a fraction bar. Because remember, these are fractions, they're also division signs. Okay, so don't let that explanation confuse you. All right, so you have 3 new rules. Okay, you have the 0 rule, you have the negative rule, and you have the dividing rule. All right.